Avid CNC is proud to announce the new Plasma EX Controller. This is a ground-up redesign of our existing Plasma controller that features a ton of new features and functionality. Let's dive right in and see what it's all about. At the heart of the system is the Centroid Acorn Plasma Controller. This is a closed-loop system that in real time monitors your arc voltage, feeds it back into the controller, and adjusts your Z height on the fly to maintain a perfect cut height. This entire system is isolated by fiber optics, so it is completely impervious to any stray electromagnetic interference. This means you'll have rock-solid, reliable cutting with low dross cuts, excellent edge quality, no matter what it is that you're cutting. Additionally, Avid CNC has made several software enhancements that make your plasma experience easier than ever before. Let's jump in and check them out. Another exciting new feature we've added is the ability to create plasma toolpaths directly in VCarve and Aspire. With our new Plasma post-processor, creating plasma toolpaths is just as easy as creating routing toolpaths. Our new Plasma control system features a built-in material profile manager. This powerful tool has all of the cut charts for all of the different types of torches that we offer and hundreds of different material types. So no longer do you have to go scouring the internet for the exact recipe for cutting. You just select it right in your controller, load up your vectors, and cut. It's that simple. Another great feature on this new control is the ability to dry run cuts. This can let you see where your torch is going to cut before it actually cuts. Another great feature on this new control is the ability to part off scrap. Directly on the control, you can select point A and point B, and the torch will cut a straight line between those 2 points. This can be great for parting off heavy pieces of material or breaking down big sheets into smaller parts. In the event that a cut doesn't go according to plan, our new control features a job restart utility. Anytime you have to interrupt a job for any reason, you can restart it wherever you'd like and even select your own pickup point. So you can have a smooth lead in and finish a job that you otherwise wouldn't have been able to salvage on another control. One incredibly exciting feature about our new EX Plasma controllers is that they now allow you to create plasma toolpaths in VCarve and Aspire, tools you're probably already comfortable with using every day. So let's jump in and see how it works. There are a couple things that you'll need to do to get set up. You'll need to have our Plasma post-processor installed. It's available for download on our site. And you'll need to create a Plasma tool. And we're going to jump in and do that right now. So first, you're going to need to go to Toolpaths and go to Tool Database and just create a new tool and give it a name. I'm going to call mine Plasma 45, and we'll uncheck set as default. And the diameter of the bit is going to be the kerf of your plasma torch, the kerf that it cuts. You can look this up in the cut charts for whatever tip you're running, whether it's a fine cut or a regular or a sync. Mine, in this case, is 0.06 inches, so I'm going to go ahead and use that. And then the rest of the settings are pretty easy. All of the toolpaths that we're going to create are profile toolpaths. And because it's a plasma, you just do a single pass no matter what you're cutting. So for the pass depth, what I like to do is give it a really big number, like 2 inches or 3 inches. And that way you can protect yourself from making a toolpath that has multiple passes. We don't have to worry about step over because we can't run a pocket toolpath on a plasma. Spindle RPM, feed rate, and plunge rate are all irrelevant. The most important one is tool number. So when you make these, really, all you need to focus on is giving it a good name, giving it the correct diameter, and making sure it's tool number 1, and your high pass depth. The rest of these settings are essentially ignored because in the new controller, you tell the controller what type of material that you're cutting. Here, all we need to do is just create a path for the plasma to follow. So let's just jump in and make a toolpath. So I'm going to use this profile toolpath here. I have set the cut depth to 0.01 because, again, that's handled on the controller, and what we ultimately want here is just a single pass toolpath. So I'll select these vectors and hit calculate, and just like that, we have a plasma toolpath. All we need to do now is save this out and we need to pick our plasma post-processor, hit save, load it up in our control, select the material, and hit go. It's really that fast. Now, there are some ways that we can optimize this path to make it cut better on a plasma. So let's talk about that. If we look at this toolpath here, these green points are the start points. Now, you may or may not, when routing, pay close attention to these, but this is where the bit is going to plunge in. And on plasma, this is where it's going to pierce through the metal and then start cutting. So if you watch a plasma, it will, the tip will go down towards the metal, touch off, it will do a big bright pierce, and then it will continue on cutting. And when it does that pierce toolpath, or pierce operation, it'll blow a larger hole in the metal, larger than the diameter of the cut. So ideally what you want when you do these pierces is you want the pierce away from the part. You want it to pierce out here and kind of swoop in and start cutting, come all the way around, and then finish up. That way you get a nice smooth edge. And we can actually do that with a couple extra steps here in VCarve or Aspire. And so the way I like to do that is we just right click on the vector, so this outside vector here, and click Node Edit Mode, or you can use the shortcut key N. And what I'll do is find a straight section here, something like right here, and then right click again and say Insert Point. And that adds an extra point in here. I'll right click it one more time and say Make Start Point. So now I've moved that green start point that was previously over here to up here. So this is where this toolpath is going to start. I'll actually do the same thing over here. I'll right click, hit Insert Point, right click this point again and say Make Start Point. And again, I did this on sort of a straight section here. On the circle, we don't have a straight section, but I'll show you how we can deal with that. So I'll just hit Escape to get out of Node Edit Mode. So now I can go back into this toolpath and we can add some leads here to make this cut look a little better. So I'll go in here and say Add Leads, and I've got a straight lead at 30 degrees, and the lead length, let's make 04, and let's just see what this looks like. So I'll go ahead and scroll down here and hit Calculate, and you can see the pierce is going to happen out here, and then it's going to come in and start cutting. So you'll get a much smoother edge on here. Let's check this one. So we have a nice outside pierce there. And if we look on our circle, we have one there as well. Now I think we can make these a little bit bigger. Maybe we should make them bigger than the kerf. So let's go ahead and do that. That's looking pretty good. And you can play around with these. I mean, there's no default setting that works for every scenario. It really depends on the geometry. I think 45 degrees in this case is going to work pretty well. And I bet you we can make this a little bit bigger. There we go. That's pretty nice. It's going to plunge outside and come in like that really, really well. So this is going to give us some nice edge quality on our cuts. So that's really it. I mean, all you have to do now is just save this toolpath out. Make sure you save it with the plasma post. And let's take it over the control and load it up and see how it cuts. Before cutting any project, you're going to want to select Profile Manager. This is going to bring up a list of torch types and materials, and you want to pick the material that matches not only the material that you're cutting, but the torch type and tip that you're using to cut it with. So you can scroll through and find the material that matches, or you can just use the search like I'm doing here. What I'm looking for is 16 gauge steel with a 45 amp torch using a sync cartridge. Now you can see here that the type and torch are available, but the sync cartridges are not. I can easily get those by going into the Profile Manager and going to File and Load Profile Set. And in here, there actually is a sync profile set that comes with the software. So once I load up that sync profile set, you'll see that my options change, and now I have not only steel and 45 amp, but I have sync. So I'm going to make that selection for 16 gauge steel, and now my material is set, and we can start cutting this project. Now that we've set our material, all we have to do is load that G-code file, zero out our XY, press cycle start, and we can cut this project out. Torch calibration is essential to getting good cuts on your machine. Every torch, every electrical environment is a little bit different, and this calibration utility will help make sure that your torch is going to run at the exact correct voltage every time you use it. The calibration process is really simple, and I'm going to show you how to do it right now. To start, you're going to want to get a good flat piece of steel and make sure it's on a part of your table that does not rock or move. You're going to be cutting about a 2-inch line, so make sure that the area for not only the grounding clamp, but where you're going to be cutting is clean and free of oil, rust, and other debris. Make sure that you attach your grounding clamp. You'll want to identify the type of metal that you're cutting. Here you can see I'm using this little gauge to check the thickness. Once you have that, you're going to go into the Profile Manager and set that up. In the Profile Manager, you'll want to go to THC Config and make sure that torch height control is turned on. If that is, you can just click Done. Next, go to the material list and search for the type of material you'll be doing this test cut on. In this example, I'm using a piece of 1/4-inch steel, and I've got a 45 amp hypertherm torch, so I'm going to find steel 45, 0.25 thick, and select that. Now you can click on the Utils menu, which is the little gear, and this is going to bring up the Utilities menu, and you're going to want to select number 4, Calibrate Torch. Press Cycle Start to begin, and note that you have to have a flat surface to cut on and a stock material profile, both of which we have. Next, it's going to ask us which direction we'd like to cut. In my case, I'm going to say X. I'm going to press Cycle Start, and I'm going to say 1 for the positive direction. I'll press Cycle Start, and then I'm going to position my torch over the beginning of where I want this test cut to take place. Here I've got my torch where I want the beginning of the cut, so I'm going to go ahead and press Cycle Start to execute this test cut. And you'll see it comes down, does a quick touch off, and then it's going to cut about a 2-inch line. And that's it. The calibration test is pretty short. So let's look back to CNC 12 to see what we need to do for next steps. It's going to ask us if the height of the cut appears to match the height of the profile cut. So in this case, I'm going to say yes and press Cycle Start. Next, it's going to ask us to inspect the quality of the cut. This is a little bit subjective, but what you're looking for is that not only did it cut at the right height, but it seemed to cut smooth, cut all the way through, there weren't excessive amounts of spatter or anything like that. If you're satisfied with what you see, go ahead and hit yes and press Cycle Start to continue to the next question. And that's it. The voltage calibration is saved and you can go ahead and start cutting. Anytime you have major changes to your control, like you replace the torch or use a completely different tip style, you may want to rerun this calibration. Every time your plasma starts a new line, it moves down in Z and touches off to the top of the metal. This is to establish a perfect Z offset height that matches the type of metal that you're cutting. This is accomplished by moving down in Z and using the ohmic touch-off to touch off to the top of the metal. This works because there's electrical conductivity between the tip and the metal plate through the grounding clamp. There are some situations where this can fail. Say you have dirty metal, a damaged tip, poor grounding, things like that. In those situations, you can use the float switch as a backup for reading Z height. The float switch is a mechanical switch that engages when pressure is put against the Z. You can see me operating it with my hand here. In the event that your ohmic tip doesn't read the top of your metal, the Z will keep moving down and that float switch will compress and trigger. If you look closely, you can see I'm simulating that here in slow motion. For this backup system to work properly, you need to calibrate the distance between when the ohmic tip triggers and the float switch. And to do that, we've made a little utility that can do this in just a few seconds for you. For this to work, you're going to need a good flat piece of metal with a clean area that the ohmic tip can read and good conductivity to ground. It's important that this piece of metal does not rock in any way. Once you have that set up in the Centroid control screen, go to the Utilities button, which is the cog in the top right-hand corner of the screen. And when you click that, this menu will pop up. Select number 1, Calibrate Float and Ohmic Offset, and press Cycle Start. You'll see a note here about having a nice flat piece of steel, which we already have. Next, you're going to position the torch over the area you want to probe and press Cycle Start. The torch tip will come down, read the ohmic, compress the float switch a couple times, and then it will calculate an offset, which you'll see on screen. And that's it. The calculation pops up on the screen, it's stored permanently in the control, and you are all set. You can rerun this utility anytime you feel the need to do so. Dry Run is a really useful feature that will allow you to live preview where the torch is going to cut without actually cutting. It will actually do all of the touch-offs and run the torch at the cutting speed, but it'll do all of it at a safe height over the top of the material. This can be great for judging to see if you're going to get really close to an edge of a part or run over a damaged section of metal before actually running the cut. From the main screen of Centroid, all you have to do is switch the dry run switch to on, and then you're in dry run mode. From there, all you have to do is load up whichever G-code file you want to run and press cycle start to run it in dry mode. And now the job will start just like its normal cut, but it won't fire the torch, and you can watch both the machine move on the table and the preview in CNC 12 to make sure everything is going to meet your expectations before doing a live cut. And that's it. Dry mode's really handy, really simple to use. No matter how good your control is or how hard you try, there's always going to be a time where you have to interrupt a cut or something just happens and a cut gets unexpectedly stopped. Well, thankfully in our new controller, we have something called restart mode. So when a job does stop, you can actually salvage your part. So here you can see this job failed about 3/4 of the way through this cut because I accidentally hit the cycle stop button. Well, normally you'd have to scrap this section of the material and go remake a new part, but no more. Job Restart is here to save the day, and I'm going to show you how to use it. To start Job Restart mode, you can press the button that's just to the right of the Z-axis control on the main screen. This will get you into Job Restart mode in the screen that you see here. The screen has several different dots here that indicate different things that happen. So the blue is the current torch location. The purple is where the job was interrupted. To save this job, what I actually want to do is pierce outside the part, lead in, and then continue cutting around it. And it's really easy to set up from the screen. First, I'm going to select the lead-in point by clicking on lead-in point in the bottom left-hand corner. I'm going to click outside the part because I want to pierce outside and lead into the part. Next, I'm going to click select pickup point, and I'm going to make my pickup point right near where this failed, right on that purple dot. So you'll see I've got a white and a red dot. The white being the lead-in point and the red being the pickup point. So the torch is going to pierce on the white, go to the red, and then continue following around the job. And if I'm happy with those selections, I can click cycle start, and you'll see the toolpath that is generated and then automatically cut. And here's that toolpath in action. It's going to pierce outside the part just like I said it. It will lead into it and then finish out the cut. And now we've saved a part that we otherwise would have had to scrap. PartOff is a simple utility that we built into the control to allow you to make a cut from one point to another point. This can be used for breaking down big pieces of material, cutting off scrap, etc. It's really easy to use. You don't need any CAM software at all to use it, and I'm going to show you how to use it right now. To access the PartOff utility, click on the Utils menu on the main screen. From there, make the selection for PartOff, which in this case is selection number 5. When you do that, press Enter or Cycle Start. You'll be given some instructions about what to do. You're basically going to mark a start point and an end point. And if you have a laser crosshair set up and installed, you get the option to do that. If you don't, you can just use the torch tip. In this case, I will be using the torch tip, so I'm going to make selection number 2. After pressing cycle start, it's going to ask me to jog to the beginning of where I want to cut. And I'm going to set the torch tip right on the edge of the material because I want that first pierce to fire through the edge of the material. So I'm very carefully looking to make sure that the center of the tip is right on the edge of that material. When I'm happy with where it is, I'm going to press cycle start. Now it's going to ask me to jog to the end of where I want the cut to be and press cycle start. You can see here I'm jogging way out past the material because I'm just going to let the torch cut all the way to the end and then flame out. I'm happy with that end location, so I'll press cycle start. to indicate that's the end of my cut, and then cycle start again to cut it. And you'll see here it's going to plunge in, pierce, and make a nice straight cut across that part. Simple as that.